Hey guys, welcome back to chemistry. So, you should have already watched this first video and then our intro video. And now we're going to be going over these notes. So, you just click on it, you download the link. You can even print these notes out and use them on the test. Whatever suits you. Let me zoom in, delete my picture. Okay, so the first thing you need to know about Gay-Lussac's law is the starting equation. Right, and his starting equation is, sorry, I'm dropping everything. His starting equation is P1 over T1, where P stands for pressure. So P1 over T1, and T stands for temperature, is equal to pressure 2, the final pressure, divided by the final temperature. So if I have a container, right, and it's at a certain pressure and temperature, if I heat up that container and I get a new pressure and a new temperature, the initial pressure divided by the initial temperature is going to be equal to the final pressure divided by the final temperature. And if I were to graph those pressures and temperatures, the graph would look like this. It's a linear graph that is positively correlated, because what's going to happen as I move to the right on the x-axis, I'm going to be moving up on the y-axis, right? And you can see that as I travel along this line, both my temperature and pressure are increasing. And that's the relationship they share. It's a proportional relationship. As pressure goes up, temperature goes up as well. So if I were to double my temperature, I would also be doubling my pressure. If I were to triple my pressure, I would also be tripling my temperature. Now, something else you guys need to know for these gas law equations, for all of them, is that you're never going to be using degrees Celsius in the calculation. What we're going to be doing is using Kelvin. Now, the conversion to Kelvin is something I taught you guys at the beginning of the year, right? Going from Celsius to Kelvin. It's been a while, so I will show you guys again how to do it. All you do is you take your Celsius temperature and you add 273. That's it. So I have this gas temperature, a gas at 100 degrees Celsius has a pressure of 100 kilopascals. The pressure is doubled. So now I know this is my initial temperature. Because the pressure becomes doubled, I'm going to have a new pressure and a new temperature. So this has to be on my initial pressure, my initial temperature, and my initial pressure. So I know my initial pressure is 100 kilopascals. So let's just write that out because that one's nice and simple. 100, there's a decimal here. What a lot of you guys screwed up on yesterday's test was that you guys weren't keeping track of significant figures. You guys knew that 100, the answer was about 193, right? And you marked that as your answer. The problem is I only wanted 2 significant figures, so you should have kept the 1, kept the 9, but this 3 wasn't significant, so the 3 doesn't round up the 9. Your answer would have been 190. Now that's yesterday's test. And this I don't want you guys to make the same mistake. And realize there's 3 sig figs here. For the temperature, this is my initial temperature. There's 3 sig figs here. Now that is in degrees Celsius, so I need to convert it to Kelvin. So I just take this, I add 273, and you're left with 373. 373 Kelvin. So I know my initial temperature and my initial pressure. I also know my final pressure. It says the pressure is doubled. So if a double 100 is 200. And I know that 100 had 3 sig figs, so I need to write this 200 with 3 sig figs. Pressure still is at kPa, kilopascals. But the temperature is something we don't know yet. What we're solving for now is the final temperature, and the problem we run into is that in the equation, final temperature is in the denominator, and you never want to solve for something in the denominator. A good first trick is just to flip it. So I'm going to flip these two and these two real quick. It'll be the same equation, it's just temperature will be on top and pressure will be on bottom. So I'll have the initial temperature divided by the initial pressure is equal to the final temperature divided by the final pressure. And the reason why I flipped it is I want this variable I'm solving for in the numerator. You never want to solve for a variable that's in the denominator, because that's going to leave you with a whole bunch of issues. So now I know I'm solving for temperature. I want temperature by itself. The way we get temperature by itself is you multiply both sides by the denominator, which is the final pressure. I'm going to multiply this side by P2, and I'll be left with my working equation. I'll have P2 times T1 divided by P1 is equal to T2. Let me scoot all this down real quick, and I'll have to rewrite that equation. So the equation goes T1 times P2 divided by P1 is equal to T2, right? And T2 is what we're looking for. So we found T1. Me scooting it screwed all that up. So let's see. T1 was our initial temperature was 100 plus 273, which was 373 Kelvin. 373 Kelvin. Our P2 goes here. Our final pressure. Now I remember we started with 100 kilopascals and we doubled it to have 200 kilopascals. 200 kPa. And then our initial pressure, well, it was 100 kPa. 100 kPa. And don't forget your decimals. This was 3 sig figs. This was 3 sig figs. Now, if I'm looking ahead, I have 3 sig figs, 3 sig figs, 3 sig figs. So my answer should have 3 significant figures. And if I put this in my calculator, you will be putting in 374 times 200 divided by 100. You'll end up with 748. Well, that number already has 3 sig figs, so I don't need to round it. That's my final answer. Kilopascals cancel with kilopascals, so my answer is in Kelvin. If you want to double check your units, you go Kelvin times kilopascals divided by kilopascals. And kilopascals does cancel, so my unit should be Kelvin. That's the correct answer because I am solving for temperature. Alright, thanks guys. Have a great day. Oh, also, make sure you guys go ahead and do these practice problems. They are right here in Schoology. Let me just find Schoology. Okay, they're right here in Schoology. You go to the Materials tab, and in the Materials tab, you scroll down to today's assignment, and you watch the videos. You take the notes along with me, and then the practice problems are right here. I do have the answers over here for you on the right for the practice problems, so go ahead and try them out, but you're not turning them in for the correct answer. You're just doing this to make sure you understand the concept. These problems are a little bit difficult. The test question is going to be very similar to the question we did in the notes. It's going to be very similar to this question right here. If you have any questions, let me know, and have a great day.